Hello and welcome to today's webcast, Building Analytics, Getting the Most from Your Data. I'm Joel Makower, Executive Editor of GreenBiz Group, here at GreenBiz headquarters in downtown Oakland, California. I'm pleased as always to welcome listeners from around the world. Before we begin, a few housekeeping details. The console you're looking at on your screen allows you to increase the size of any of the panels by clicking the full screen button on the right-hand side. If you have questions for today's speakers, simply type your question or message into the Q&A window at the bottom left of your screen. That is also a chat feature on the bottom right that allows you to interact and discuss the content of today's topic with other webcast viewers. If you have any technical difficulties, there's a help button that's located in the upper right corner of your screen. A couple more things. You can download the slides from today's webcast by going to the Download Slides pod on the bottom right of your screen. Also, you should know that today's webcast is being recorded and will be available on demand starting in a few hours. And finally, if you're on Twitter, the hashtag for today's event is GRNBZ. Feel free to share what you're learning with the Twitter sphere. So let's get going. Well, you've got a dashboard, specifically one that gives you real-time data on the operational performance of a building. Congratulations, but that's only a start. The next generation of building analytics go beyond reporting what's happening now or in the past few hours. They take a predictive look at what's likely to happen given a wide range of factors. That takes building operation and optimization to a whole new level. Today we're going to look at the next generation of building analytics, including what's out there now and how these tools are being used in real-life settings. Joining me today are Jill Feblowitz, Vice President of IDC Energy Insights, Scott Herman, Director of Product Development at Johnson Controls, and Peter Dickinson, Chief Technical Officer of BuildingIQ. After we hear from Jill, Scott, and Peter, we'll take your questions. You can type them in at any time, starting right now. Jill Feblowitz, take it away.
Thank you very much. Today I'm going to be talking to you about smart building analytics, and we'll start by getting a little context, talking about what a smart building maturity model is, looking at the analytics to help you get to smarts and what you have to have in order to get there. Take a look at the technology stack, which is a slightly different perspective. Describe some analytic uses that smart building owners and operators are currently using, and provide some guidance on how to go forward. So in terms of context, making buildings smarter and optimizing their energy use is a big opportunity for building owners and managers. The market for tools and services to help in this process, we feel, will grow rapidly over the next few years. In fact, IDC Energy Insights has forecast that the global smart building market will grow from $5.5 billion in 2012 to $18.1 billion in 2017. That's a CAGR of 27.1%. Why? In large part because energy costs for U.S. commercial and industrial sector are growing and are greater than $200 billion a year. In addition, current buildings are estimated at only 30% of achievable energy efficiency by Energy Star. And then, according to EPA estimates, commercial and industrial energy use accounts for 45% of total U.S. greenhouse gas footprint. So IDC Energy Insights has looked at how to get from a baseline to really having an optimized building that helps you save energy, reduce your carbon footprint, and also make better capital investments. IDC Energy Insights defines the smart building as a facility that utilizes advanced automation and integration to measure, monitor, control, and optimize operations and maintenance. This illustration that you see is intended to guide you through the process of developing a smart building, campus, or portfolio of buildings. Each building may start at a different point on the spectrum based on the existing building energy management infrastructure. What's important in the context of this webcast is that analytics and data management play a vital role in facilitating this transformation. The key concept is optimization, meaning the deployment of a set of systems capable of adapting in real time to both internal policies and external signals. These systems manage how building equipment operates to use energy in the most efficient and cost-effective way. The technology infrastructure of such optimized smart buildings is defined by integrated control systems that automatically change settings and operational parameters utilizing information technology architecture. Analytics and data management are essential components of smart buildings. These tools accommodate the increasing volume of data associated with the instrument and connected equipment in the facility and make this data operational and actionable. So what are the pieces here in getting to the smart in smart buildings? Well, in one respect, in a very simple respect, you can have reporting dashboards that use your existing systems and existing data at the system level. For example, lighting controls being a system or HVAC another system. You can look at that historic data. You might not have building software, but you can get some visibility and some management of the building by operational staff who manually react to information from that reporting dashboard. The next more sophisticated level of technology is alerting. And here you find fault detection and diagnostics. So if there's a piece of equipment that was switched off and it shouldn't have been, or switched on that it shouldn't have been, and there's a waste of energy, you can find that out. The control systems and devices involved here are building management systems or building automation systems, sensors and submeters. The data is usually high-frequency data, and it's current rather than historic. And there are some conditional rules that help you get through the kind of mess of alarms that could potentially occur. And finally is the optimized building, which is proactive, which makes use of advanced analytics. There's a lot more data involved in this type of analysis. In addition to the control systems, which we mentioned before, there might be wireless sensors and more submeters. Or there may be data coming in from peer buildings or external data services, such as weather data, or data that provides information on building occupancy patterns. Then there's the analytics software on top of that data to do prescriptive analytics, kind of recommend what you should do, predictive analytics, what will happen with the building, optimization, what are the best settings that I should have considering the current conditions, and even building simulation of what would happen if you set lighting at a certain point at a certain time. So these tools vary in their ability to provide a facility manager or others in the building with the ability to make better decisions, so that's decision management, or they can be fully automated, where what's found in the analytics will result in an automated decision. The next slide shows a little different orientation of how we look at the technology stack for smart buildings. And the purpose of this slide is to really let you in on the fact that there are vendors in each piece of this technology stack. There are vendors and suppliers of smart building services. There are vendors of instrumentation, which also may be vendors of building control systems. There are IT vendors that might have generic applications like data warehouses and middleware and extraction middleware, which might allow you to extract different data. There are different communication protocols in use that allow data from very different pieces of equipment to be communicated with. And then finally, on top of all that is smart building analytics. What we see as a major advance for smart buildings going forward is the ability to have platforms that help bring together the data in all the underlying systems and instrumentation, and also are open enough that they will allow different analytics applications to come together, including those applications that are developed by the facility managers themselves, to really make a smart building. So how are analytics being used right now? Well, this slide is really kind of a look at some of the analytic uses. And these analytics can be performed on-premise or in the cloud. So inefficiencies can be identified in a number of ways by understanding the use of an individual circuit or analyzing that use over time and comparing it to standards. You can identify anomalies and then resolve them through detailed adjustment of equipment or upgrade. Simulation or what-if capabilities are useful in planning and understanding future events. For example, pre-cooling a building to shift load from an anticipated pricing event will have some impact on a tenant's comfort. So it's critical to understand the value of that response to develop an effective strategy that balances the needs of the grid, anticipated financial benefits against comfort or discomfort. Managing a large building with potentially hundreds of sensors and control points is an extremely complex problem, and to optimize condition requires an understanding of potential interactions and propagating constraints that typically requires automation. And then finally, predictive maintenance is critical for managing the cost of repair and capital investments of that facility. So here's some guidance for you going forward. We think that it's important for you to be able to inventory existing building sensors and management systems. And the reason is, in the words of one facility manager that I talked to recently, each building is a snowflake. So you may have a variety of different systems and a variety of different communication protocols. And the building itself may operate with different functions and different equipment that all make it unique. So it's really important to get that foundational understanding. One common obstacle is that the management of many buildings is that there are departmental barriers between information sharing and coordinating planning. So facilities management and energy procurement and fire, safety and security might have all their own views. But they never really get to share information and collect contributions from all groups involved. So it's very important that you take a look at all those stakeholders and make sure that you bring them together. In the end, it comes down to people, and without a champion to drive a facility or a group of buildings towards optimization, uncoordinated efforts will fail. Without building facility staff to buy into the Smart Building Challenge and the training to make them effective contributors, little progress can be made. Finally, it's important to model and consider a range of benefits, not just energy savings and controlling operational costs. Smart buildings generate less greenhouse gases, helping a company meet their corporate sustainability goals. Many cities and states have set aggressive energy reduction or efficiency goals, so smart buildings help with that. And finally, by optimizing energy use and lowering operational costs, a building can become more valuable to an owner and a valued source of pride to existing and potential tenants. So that's all I have right now. And I know, Joel, you've probably got some questions.
I've got a couple for now, and there'll be more later. There's some great questions coming in. Keep them coming in. First of all, somebody asked, in that technology stack that you showed, Jill, where does IDC Energy Insights sit?
IDC Energy Insights?
Yeah.
We don't sit anywhere. We are an outside observer, and so what we do is take a look at all the players that are in this market and help building owners and facility managers and energy procurement folks and all of those folks really understand who the players are, what does their technology contribute, what are some best practices in putting all the smart building technology together. And we're really a research advisory firm. So we look at it all, but we don't put it together.
Great. And one other quick question. You mentioned the forecast of smart building technologies going from about $5 to about $18 billion in the next few years. Do you have information on how much of that's retrofit versus new construction?
I don't off the top of my head. I will have to go back and look at that, but I'm happy to send an email out to all the participants here if we have that data.
Any just sort of off the top, just your thoughts, your hunch on that?
So my guess would be that more, it would be like maybe a 60-40 split or maybe a 70-30 split with retrofit being on top. And the reason I say that is because these are things that can be put in and use existing systems, and they're an analytics layer, and they're a lot cheaper to do than massive building retrofits. So I would say that putting in smart buildings is kind of the low-hanging fruit for a lot of commercial and industrial buildings.
Great. Well, thanks. We'll come back to you with more later. Now let's move over to Scott Herman from Johnson Controls. Scott?
Good evening, good afternoon, and good morning. Happy to be with everybody today to talk about a very exciting topic for me. The title is Getting the Most from Your Data, Fault Detection and Diagnostics. So let's dive right in. First, I'd like to establish a working definition of what fault detection and diagnostics is. As you can see on the slide, the definition we have here is tools for the early detection of abnormalities in systems and the diagnosis of causes to support corrective action before additional deterioration or loss of service occurs. Lots of words there. What I would suggest is there are two key phrases there which get to the detection and diagnostics. Detection of abnormalities and diagnosis of causes. As you can see on the slide, before we dive into an example in our space in building efficiency, I wanted to have a working example from an adjacent space that should resonate with all of us. So we have both aviation and healthcare here as examples of good application of FDD. Let's talk a minute about aviation. General Electric currently is using FDD in over 25,000 installed engines in planes flying worldwide. Diagnostics not only reduces operational interruptions by avoiding major engine performance and maintenance issues, but can actually increase the engine's time on wing. This allows for the airlines, GE's customers, to make optimal maintenance and logistical decisions using condition-based maintenance. They will actually schedule the planes to fly routes based on when and where service work could be done. For example, if an engine has met a condition in which it needs maintenance, the airline will actually strategically route the plane through commercial flights that will place it in the vicinity of a shop capable of the maintenance work. Pretty cool stuff. I'd encourage all of you to research this further on the internet. It's some pretty interesting articles from GE in this space. Now let's talk about our space, building efficiency. Fault detection is the recognition of undesirable abnormalities occurring in equipment, systems, spaces, and/or buildings. A few examples of equipment are here on this slide. Fault diagnostics is the isolation of these abnormalities, aka the root cause. A couple clarifications around these definitions. Detection does not require understanding or determination of the root cause of the fault. It is simply the detection of the fault. And a fault does not have to be the result of a complete system failure. Fault detection and diagnostics is also not alarm management per se. One of the common terms in building automation and building management is alarm management. Really, the fault is a recognition event that could become an alarm. An example, in a building automation system, a zone temperature, which is hot or cold, could be an indication of several root causes or faults, but an alarm would be around the zone temperature itself. We're going to go through some examples of FDDs in the building efficiency space in a moment. Let's step back for a second and talk about Panoptix, the solution we at Johnson Controls have provided. I include this picture to simply show, and Jill mentioned, and Joel did as well, both cloud and on-premise solutions can be combined to look at what's happening in the building, which is at the bottom of the slide, different information from utility providers such as bill information, and most importantly, turning that data into information for building owners and operators. Let's go into a couple specific examples. I'm going to talk in a moment about two very different kinds of FDDs, the first of which is rules-based FDD. Here's an example from the Panoptix Continuous Diagnostic Advisor of a rule which is showing simultaneous heating and cooling fault. As you can see on the screen, there are several graphs of data. If you look in the middle of the screen, you can see a red line. That's where the fault was shown for this example. What we have here is a piece of equipment which is actually calling for heating and cooling at the same time. Unless there's a specific dehumidification strategy in place, this is probably indicating a fault either in the equipment or the control strategy. This is a simple condition which was met by looking at two different variables and writing a rule to detect that. Let's talk a little bit about going beyond rules. So certainly Panoptix and other systems have rules-based analytics, which are really defined by building efficiency experts and look at different variables and trigger an event. Beyond that are a set of statistical methods for determining faults. Let's talk about three in particular. Temporal analysis relates equipment performance to or not limited by time and frequency simultaneously. This is identifying how a piece of equipment should operate based on past performance and then bucketing that performance into a typical performance of a given time period. If the equipment operates outside of the typical performance for that given time period, a fault will be triggered. A simple example of this is looking at zone temperatures over time. There will be patterns with those zone temperatures that get set points. And if those patterns start to deviate, a temporal analysis fault may be triggered by these powerful analytics. The second type of statistical analytic I'd like to talk about is regression analytics. This is a statistical process for estimating the relationships among variables, thereby projecting expected performance. This is used in complex equipment and systems, for example, a chiller. Similar to machine learning or building learning, in that the machine or building learns how it is supposed to behave given operating conditions, a fault notification is triggered if the expected performance does not occur. Predicting the performance of a piece of equipment based on the current operating conditions and triggering a fault if the performance is not met is key information for the building occupants and operators. The final type of statistical analysis I'd like to speak briefly about is peer analysis. Peer analysis identifies anomalies amongst groups of like equipment that are expected to operate with the same control strategy and objectives. This statistical method identifies which pieces of equipment are not operating the same behavior as the other like equipment. A typical example would be many VAV boxes being served by the same air handler will tend to have the same behavior over time, and if one or two of those VAV boxes is operating outside of that norm, this type of fault may trigger a call to action by the occupants and facility team. We really call all of this achieving a new normal. In Jill's presentation, she mentioned that each building is like a snowflake. What these statistical analytics will let you do is really get to understand each snowflake and establish a new normal for that building so that faults are really specific to that building and that facility. Finally, I'd like to end with an example of a case study from one of our clients, and this really brings home what the capability of advanced FDD can do. This is Western Kentucky University. In its first 120 days in using our continuous diagnostic advisor application, they detected a range of building system faults such as improper sequencing, improper valve and damper positions, improper ventilation, and missed opportunities to reduce peak demand. In addressing the faults, as you can see by some of the quotes here, WKU achieved two overriding goals. Number one, the university created more comfortable learning environments on campus, and number two, from a financial aspect, they recovered their investment in this continuous diagnostic advisor in less than 6 months. There's lots of exciting details on this topic, but I think I'm going to turn it back to Joel for questions.
Yeah, great, thanks. Maybe you could, Scott, explain a little bit about how Panoptix fits into this. Is it a tool specifically for fault detection, or is it part of a larger management package? Because I'm not sure if that's clear.
Yeah, thanks for asking that. The Panoptix is a complete building energy management system with a off-prem solution, cloud-based, which has many different components. We do energy reporting, we do some performance monitoring, we also have the ability to share data with other applications. Continuous Diagnostics Advisor is just one of the applications germane to today's topic.
And one of those applications, I believe, is BuildingIQ. And we're going to hear now from Peter Dickinson, the CTO of that company. Peter?
Thanks, Joel. So I'll dive right in and talk about the industry progress there. This is a space I've been watching now personally for 15 years since getting involved. And I think this matches up very nicely with what Joel was talking about and where BuildingIQ sees the industry moving. That, of course, we had those huge gains in the early 80s, mid-80s with the rollout of the direct digital control. But of course, you know, given the limitations at the time of processes, user interfaces and the like, engineering standards, you know, only as good as the operator. no awareness. And awareness is a word I'm going to talk a little bit more about. Now, the business I was involved in for the first 10 years of my career was in this sort of central space around collecting real-time data, centralized experts making recommendations. But at the end of the day, still relying on a person to go out and fix something. And that's still going to be necessary in a lot of cases. We see fault detection largely and diagnostics largely helping folks in that space, so that it's less time pouring through data, less time reviewing screens, and more time actually rectifying the faults. But in some cases, there's the opportunity to go even beyond that. In the fault detection industry, we see the opportunity for some faults to potentially be self-healing if the system can drive and try and get itself sorted out before calling on an operator to do something. But in that next step where we operate, we have a technology that continually builds awareness. I think that snowflake example is so spot on, that every building is a snowflake, and every building manager has a very different building to look after. So the solutions that we see coming out now that are going to have the most success allow for customization for that building. And much like the fault detection, we use mathematical means to do that. And essentially, in short, we use the philosophy that every building is a snowflake, but you can't change the laws of physics. So our mathematical physics-based model can learn the specifics of that snowflake and get to know it. So we're delivering that as a service, and we're driving the building towards savings. And I think it's important that as we look at the industry and the retention of jobs and the retention of skills, there's a risk here that, first of all, that this sort of technology could be looked at as replacing the control system, and I don't think that's what we're intending to do. There's the opportunity here for people to complain that perhaps operators are being replaced, but I think there's a certain specific set of criteria where the big data, the analytics, and the supervisory control has a role where either there's just too much data coming in, it's too continuous because there might be decisions that the system can make in the middle of the night, 24/7, and these sort of things where a computational-based approach proves to be much more powerful for certain aspects. Probably not so much for liaising with tenants and engaging with them on sustainability matters. I don't think the computers are quite there yet. The other thing is, talking about these snowflakes and looking after large volumes of buildings, is they're all a little different. There might be different underlying vendors, and the cloud is giving this great opportunity to unify buildings into a single portal, a single view. For anybody that's had to look after more than a handful of buildings, it can be quite difficult without a significant investment to keep track of those buildings, know what's going on, and get insights into them without, calling up the management staff in each one of those buildings. So there's that need there to unify portfolios regardless of what's the underlying system. So in our interpretation of that thinking, we take in a range of information from weather forecast data, time of use information, demand response signals. We have occupant comfort information coming in. That's all hosted in the cloud with a small on-site component where we work with the likes of the Panoptics, or we might have to install our own device on site. This gives us access to the site, that reading that information back from the building, producing an optimized profile that I'll talk about shortly, and sending it back to the building.
1719.
Okay, so just to get into some specifics here about the visualization aspect here, if we take a quick look at a standard building, the purple line that we have there.
943.
I'm sorry, people might be having trouble. No, I'll continue on. So the set point in a traditional building is held steady throughout the day. From whenever the plant comes on, it's working to maintain a certain set point between some sort of limits. There might be deadbands or the like, and we see the ambient temperature there. Now, the important thing about the BuildingIQ approach is equating all that subtlety, all the things that go into maintaining that temperature, and translating that to a power profile. So if we look at a standard way a building might be operated, we have that startup peak and then ramping through the day to maintain that set point. Also shown on this graph here is a baseline model where we can very accurately, through that knowledge of all those underlying systems, know what the power use is going to be. And that would be quite useful on its own if we use that as part of our measurement verification. We can monitor times when the system is operating without the BuildingIQ control going on, and we can develop a standard operating profile for the building. But where it gets really interesting is where we look at the degrees of freedom. Now this is where the complex analytics and the high computational load comes in, where we look at making small temp variations, and this is just one example of a day here, where we have an optimized temperature profile for the building where, we're definitely within the maximum and minimum limits at the time of occupancy. We might intelligently drift to one or to the upper or lower limits of the day, inject cooling or heating when we need to. And this is the result of thousands of iterations of an optimization process that makes use of so many things that have come together to enable us to do this. It's the combination of platforms like Panoptics and standards like BACnet. It's the availability of high load computation in the cloud, and all of the other web infrastructure that goes along with that. So we run thousands of possible iterations to find the optimal operating profile for the day, and then we send that down back to the building as guidance for the day. And the result is this, where we see a large drop where we've shifted loads around, and this is a fairly simple example, but if you overlay this with perhaps time of use pricing or real-time pricing or demand response events, the ability to shift those loads around and make use of that mass of the building can be quite significant. So just as a quick case study here, one of the largest buildings in New York, when we're seeing significant savings from what is essentially just a software solution. And that's what BuildingIQ is about, delivering that software backed up by experts, and providing a new way, a new paradigm, a shift in the way those degrees of freedom that are available in every building. Even though each building is unique, we find a way to tailor our system to meet the needs of that building, driving it within those degrees of freedom to deliver significant savings with very little capex. It's just operating as a software service.
Oh, okay. You're done. Good.
All done there. Sorry.
Okay, sorry.
Keeping an eye on the time, I want to get into the gnarly questions.
Yeah, great. Tell a little bit more about BuildingIQ in terms of where it fits into the technology stack in the cluster of things that are out there now.
Well, I think hopefully we're occupying a corner that's upwards and to the right, where we're doing something that's a little disruptive. It's there's the potential for a little bit of discomfort. There's a control aspect happening that's going on from the cloud. So it's going to somewhere in the stack where there's sort of cloud, the analytics happen, but it's also connected to the building. So if we were to extend the stack to go beyond building up towards the smart building and into the smart grid, we see ourselves as a technology piece that's behind the meter that acts as that link between the building, the smart building, and the smart grid, which is a very challenging space. And one of the reasons we are a big fan of the Panoptics platform is in that that in-building fulfillment piece is an area where we've had to invest a lot of our own development time. But a lot of other startups with great technology, it's a significant barrier to getting innovative, potentially disruptive new technology into that stack, where you've got to invest a lot of money essentially in reinventing the wheel. And in this case, the Panoptics platform really can help a lot of folks, including ourselves, in avoiding reinventing that wheel.
So talk a little bit about the relationship between BuildingIQ and Panoptics, how you guys play together, how BuildingIQ fits into that platform.
Wow, I mean, it's ironic that I'm talking into an iPhone right now, because the parallels are really there. That the Panoptics platform acts like the Apple ecosystem with the platform and an app store, and we could take our successful application that's operating elsewhere and package that up to sit on a platform. It's a philosophy that we've all now become familiar with in the last 5, 6, 7 years, and we think it's great for that reason I was talking about before. That it lets us focus more and more so on the intelligent technology, advancing their algorithms, making our algorithms learn more about those snowflakes and find more savings in the building, and less time on the actual connection to the building, which folks like Johnson Controls and other vendors in the space, that's what they're really good at. They know the buildings, and they know the underlying systems and how to talk to them. And we've had to do that, but if we accelerate a few years and platforms like Panoptix become more ubiquitous, we would have never had to make that investment.
Well, we'll have some more questions about Panoptix coming up, but before I want to ask Jill, somebody asked, we tend to jump right into the so-called solutions, but pointing out the efficiencies are the result of some underlying issues. The person writes that analytics can only be effective if the rule sets are written based on our understanding of the issues. So what are those issues? What do you see, what do you consider the core issues today with buildings?
Well, that's it's kind of a broad question, I think, and I think it has to do with what the building use is. So you might have the core issues with a hospital facility being different from a refrigeration warehouse, and where some of the issues might be related to HVAC and HVAC performance or systems performance. They might be related to lighting performance. There's a whole host of things, and I think that one of the things that analytics is good for is to be able to, at least within building functionality, to be able to understand what are some of the rules, what are some of the things that you have to look for and notice. And there has been quite a bit of research done on this in the past, mainly related to energy efficiency programs, with audit programs. So I think that there's a lot of knowledge out there. I think what the analytics bring is that ability to take all that knowledge, synthesize it, develop some rules, and then have those rules kind of end up being automated, so you're constantly building the right knowledge that you need.
So let's talk a little bit about Panoptix and specifically how it scales. What's involved related to costs in scaling Panoptix over a large distributed organization? Someone asks, like an urban K through 12 school district, or any kind of small campus, whether it's in education or corporate sector. Scott?
Yeah, good question. The way Panoptix scales is whether it's a small individual standalone building or a large enterprise, we've created the oversimplified Panoptix really works in 3 areas of the technology stack. Connectivity from a building to off-premise, then the analytics and business intelligence off-premise, and then showing that as insight to the customer. So specific to the question, whether it's a single building that's isolated, which tends to be less and less these days, or a enterprise-wide global Fortune 1000 company, we have different connectivity solutions to make sure at the end of the day we take the existing data that's in a facility, whether it's through a building management system or a simple meter, and get it to where we can apply the intelligence.
And is Panoptix only available as a system as a software, or what does it run on, or is it standalone?
Currently, Panoptix is a software as a service offering, where as long as you have a internet connectivity to the cloud technology, we can connect your building or suite of buildings to the applications.
And you provide the call support and software post installation. What else is behind that?
Yes, it's a good question. In addition to the actual software and the analytics, part of the power of us having this within Johnson Controls is our service and our live guide support through both the web and our field structure is there to support you along the way.
Peter, there's some questions related to some of the ROIs you talked about. What are some of the ROIs of most customers? Scott used an example, I think, of 6 months. It seems small. You showed a 15-month one for $600,000 savings. Talk a little bit about what you're seeing out there.
Sure. It's always a little strange talking ROI with a subscription-based service. The way we normally try and talk about is that for every dollar spent, our customers, we've typically seen on average between, at the low end, perhaps $1.25 return up to $2 or $3 for every dollar spent. A couple of freakish cases where people have seen a $5 or $6 return for each dollar of subscription. So it does vary a little depending on climate, the aggressiveness of the tariff structure, availability of DR, but that's essentially we think anything that's above that break even, where all of the other benefits that go along with those savings, the impact on an Energy Star score, the potential for some lead points, it's very exciting. And when you take the capex out of the equation, it often puts the conversation into a very different light from most of us who've been so used to justifying those big capital projects, where we're saying come in with a very light touch, just a monthly subscription, and it's making savings from very early on.
We've got a number of questions, and I want to talk to all three of you about this, about where these markets are unfolding, these markets for building automation, who the early adopters are, what are some of the sectors we're seeing, types of buildings. Someone asked specifically, do you have municipal examples of all this? And someone else just asked, when will all this begin? Jill, let's start with you. Talk a little bit about how you see the market unfolding.
Yeah, so I think from our forecast, we see really, in terms of regions, North America being still, and Western Europe being a substantial part of this particular market, and those are the ones with the biggest growth rates from 2012 to 2017. I've seen a lot of early adoption in the areas where there is government interest. The GSA, for example, is one area. There's a tremendous amount of interest and adoption in campuses. It makes it really logical, plus it's a great teaching experience. Some of the high-tech firms, and especially those ones who have pretty strong sustainability objectives, have really invested in this. I think Microsoft just came out recently talking about how with an upfront investment of less than 10% of their annual energy expenditure, they have a expected payback period of less than 2 years, and that's for a pilot program. So those are some of the areas where we see the early adoption.
Scott, what about you? What are you seeing?
Yeah, feeding off of what Jill said, maybe not so much on geographies, but talking about the different vertical markets, we're seeing a lot of early adoption in government at all levels, municipal, state, federal. Town of Wake Forest is an example of someone that's gotten on board with us early and is seeing good returns. Also in education, both higher ed, we mentioned Western Kentucky, and all the way down through K through 12. And then a big vertical market for us in general, but also I think an early adopter of this, is healthcare and hospitals. So while we're seeing pretty good penetration across the board, those three have really taken off very early with some of this technology.
And Pete, what are you seeing?
Well, I'm most excited at the broader scale with the utilities now talking about the combination of demand response and energy efficiency, finally seeing those two areas that are typically siloed within the utility coming together. That's clearly a huge opportunity which touches on a broad range of buildings. Could be anything from small mom and pop retail, 70,000 square feet or less, right through to medical office buildings and large towers. So that's a very interesting area for us. We also like the vanguards of the real estate industry who are willing to push the envelope, mostly because they have they've exhausted a lot of the early avenues, the low-hanging fruit. They've done the lighting upgrades. They've got latest controls, perhaps on a retro commissioning pro. They're looking around at what else can they do to maintain that almost sort of bragging rights about being at that forefront. It's another huge part of the industry which is very capital constrained. It might, for one reason or another, need to get that Energy Star score up. So subscription services like fault detection and optimization are a great way for them to either boost that Energy Star score for without having to find the capital, or perhaps they've lost some of their talented engineering staff, and this is a way to supplement the skills that still exist in that organization. So they're very interesting. But I think the one hidden gem that is the most interesting one here, and I saw a question about the size of building. We've put a lot of effort into getting our solution. I think this also applies to fault detection and other more automated, it's any of the software-based solutions that are coming out that will avoid the need to send an engineer with a clipboard to site for days on end, means that we're going to finally open up a huge raft of small to medium businesses that have typically been neglected by the retro commissioning industry because it's so hard to get into those buildings, neglected by the utilities because the utilities, despite utilities' efforts, it's very hard to engage with the smaller and medium buildings. And so, as exciting as it is to see the, case studies like ours, hearing Clay Nestler from Johnson Controls talking about the work at the Empire State Building, 90+% of those buildings, the buildings that are out there, dying for energy savings and really significant benefit for those smaller businesses, medium industries. That's where these platforms are making it easier to get intelligent software into the hands of those customers. I think is one of the most exciting areas for the next few years.
Well, let's stick with this sort of theme because at some level, all this sounds like a relative no-brainer in the sense of the pretty good paybacks, whether it's 6 months or 15 months, all within the realms of acceptableness. What are you seeing? I'll start with you, Peter. In terms of what are the barriers to the uptake of this? Is there resistance? Is there skepticism? Is it financial issues, lack of education? What is keeping this market, or what will it take, I guess, because this is a new market, what will it take for this to scale? What are you hearing as resistance in the marketplace?
Well, that is the million-dollar question. Using Bay Area talk, it's like what's going to be the thing that helps us cross the chasm? And I think the interoperability that's just taken another step up with the likes of the platforms such as Panoptics is great, because it starts to show that the large vendors like Johnson Controls are starting to welcome others into the solution set in a more integrated fashion. Of course, partnerships with the big vendors has been something that's existed for a long time, but here we really see it deeply ingrained with justification, because one of the big barriers is, well, I've just spent a lot of money on a control system. Why do I need to add these other things? And this is starting, we're starting to get some momentum where people are realizing there's other things that can be done. The underlying fundamental control system can be very good at what it's doing, but there's a range of other things that can be added on top. It's that app thinking that I think will help drive people there. But there's still, there's the usual fear, uncertainty, and doubt. I'm a little jealous of fault detection since it doesn't have the control aspect to it. But then because we do take that extra step and BuildingIQ takes control of the building, takes that risk, we actually drive towards the savings. So, there's all these little double-edged swords, and will this initiative compete with this other thing here? Or I've got a very specific tenant on this level which I can't afford to lose. So, how we overcome those concerns is still a bit of a problem there, because, we can reach a lot of great participants like we got on the call today, but there's still a lot of folks out there with great potential in their buildings who aren't engaging in the conversation.
Great. Scott, what are you seeing?
Yeah, I'm going to feed off of what Peter just talked about. The industry has been very fragmented for years, and if you look at any small, medium, or complex facility, there's a lot of equipment and a lot of controls from a lot of different providers. And in the past, if we're being honest with ourselves, most large product and service companies like Johnson Controls have not been very open. So Peter mentioned the platform. It also needs to be an open platform. Just the fact that Peter's company and our company are working together, instead of fearing the technology of others in this space, we're embracing that and really trying to connect all the systems in the building so that anybody with a really nice piece of intellectual property to help us advance the green space can do that. So the barrier has been not only on the industry side, but getting acceptance that an open platform is a good idea, and it is. So we're really trying to embrace that.
And Jill, do you see the same thing?
Yes, I do, and in large part because of the heterogeneous environment at many buildings, especially the larger, more complex building as you go. Just the thought of getting the systems to talk to each other and being able to take the data and normalize it and make sense of it is, has been a huge barrier.
Jill, you talked earlier about sort of the other benefits that some of these technologies afford to building owners, operational costs, sustainability goals, regulatory compliance, building value, and tenant satisfaction. Are those quantifiable? Operational costs, yes, obviously, but some of the other ones seem less so. But are we finding that we're able to quantify them, and how much of those are snowflake-like, unique to each building?
Well, I think the sustainability goals are quantifiable, and mainly those can be really derived from what the energy and water consumption is of the building. So you can do those pretty directly by applying some formulas. Regulatory compliance, where there are standards, yes, I think you can quantify that. The building value and tenant satisfaction, those are more soft benefits. And I know that, I've been around the energy efficiency industry since the early 90s. And we had been talking since then about, even on a residential level, having some kind of recognized real estate value associated with greater energy efficiency. And, I think that challenge still exists today in commercial and industrial and in residential as well. And there's starting to be some progress in recognition that that's a valuable attribute of a building. I think there's a way to go, so I see it more as a soft benefit, and the tenant satisfaction at this point as a soft benefit as well.
Mm-hmm. Scott, I've got a couple more questions about Panoptix. First of all, can Panoptix predict equipment failures?
Through the combination of the statistical analytics and sort of setting the new normal for the building and then the operator insight, it becomes predictive. One of the things, if you think about the definition I provided for detection and diagnosis, those alone are not predictive. One of the terms that's emerging is prognosis, and prognosis is really the ability to predict future abnormalities and recommend proposed preventive actions. That's something we're working on right now. So the short answer is yes with an asterisk. I believe over the next 6 to 12 months, the actual offering will provide the specific corrective actions as a prognostication. Big word to use.
Yeah, easy for you to say.
Yes, exactly.
Someone also asked about, is Panoptix focused on BMS, building management system, level data extraction only, or can you manipulate the different set points? In other words, are you just looking at data that it's producing, or can you actually adjust different temperatures and controls along the way through the platform?
Yeah, the current commercially available offering is focused on looking at energy data and other data. We're currently working, and Jill mentioned this in her presentation, integrated control, providing that two-way communication to the facility. The challenge is making sure that the building automation system is focused on controlling the building, and that things like Panoptix are allowing insight back to the building to take corrective action. Some of the examples, classic examples, would be demand response. If we get an event from the grid, we want to take action in the building. So integrated control is a mechanism to do that.
Yeah, and this sort of goes to the earlier question. One of the things that seems to be happening here is not necessarily predictive yet. That's coming up, as you said, but it's a lot of it's really about responding, identifying things quicker, and then responding to them more quickly, as opposed to going out every few years and people with those magical clipboards actually inspecting things. You can get a lot more information in real time and not only know that something's wrong, but what's wrong so that someone can go out with the right equipment. That seems like a huge boon for building owners. Scott, am I explaining that correctly?
No, you're explaining it very well. The key is that instead of walking around with the spreadsheets and kicking the tires on the equipment and using tribal knowledge, and there's a lot of it out there, have the system tell you what's going on and give you insight on what the corrective actions are. We are finding, as in the case with the Western Kentucky example, part of why the payback is very attractive is the labor-intensive steps that were fairly repetitive manual in the past can now be done by the software, and the individuals in these roles of facility management and energy management can focus on projects and initiatives to actually reduce the various waste in the facility instead of running around being human calculators. So you're spot on.
What's the role, and Peter, I want to start with you on this. What's the role of tenants in all this? Does the technology afford the ability for tenants to play, or occupants, really the building occupants, and at least in terms of employees working in the buildings, play more of a role in understanding or helping to monitor the building and identify where there might be problems?
Well, absolutely. I think engaging with those occupants is definitely important. But one of the things I like talking about tribal knowledge is that in our solution in particular, we've tried to address the latest thinking from ASHRAE with the ASHRAE 55 comfort standard, and that's a big step forward. There's opportunities to survey occupants at different times and find out a lot about them. But I think there's also an aspect here on that relationship between the occupant and the facility engineer, where right now that phone call or a potential complaint from a tenant is the most real-time piece of information that they have. And the other two things that kind of level off perhaps that phone call complaint is the energy bill that might come in once a month, and that Energy Star score that comes in perhaps once a year if you're doing those regularly. And by having awareness of the relationship between comfort, energy cost, and raw energy consumption, we can now start to level off those three different voices, not to try and downplay the input from the tenant, which is obviously critically important, but it's very easy for a facility engineer to address a complaint in real time without the awareness of how that change is going to impact that bill that's going to come at the end of the month and that Energy Star that's going to come at the end of the year. So this is a great way to get those three things happening in unison and with each with a real-time voice, if you will.
Scott, how do you see the role of facility managers changing as this technology becomes more common? Does it require changes in how they operate, and what's the kind of training that's required for them?
So I would answer that in two ways. Specific to how the behaviors and how they spend their day will change, as I mentioned earlier, I do believe we are going to help with all of these various technology pieces. Facility managers be less tactical and reactive and be more proactive to plan initiatives. Specific to the training and insight, one of the things that we are trying to provide where the software as a service model works great, the applications that Peter and I are talking about update very frequently because in a SaaS model they're easy to update. It's key to not only provide interfaces that are easy to use and learn, but that we have training and insight available. One of the things specifically we do with Panoptics is assign a live guide, which is a human, to each of our clients, and via either the phone or web technology, they have that person almost as a Sherpa to work with them at all times. Yeah, so I do believe the facility managers' lives are going to get easier so they can focus on the things that they're being judged on and not the tactical responses from the building.
Yeah, and Jill, finally, any estimate on the market for training facility managers and others to manage smart building systems?
Not yet. We'll put that on the list.
Okay, it's on the list. Well, like any good snowflake, we're going to melt away any second, so I'm going to close the questions on, and for now, we've got a lot more on things we haven't gotten to, like a number of questions on residential systems, which is a little bit out of the scope here, but we'll save those questions for another day. I want to thank Jill Feblowitz of IDC Energy Insights, Scott Herman from Johnson Controls, and Peter Dickinson from BuildingIQ for a great conversation. And thanks to all of you for your participation and the great questions you've asked. As always, for the latest news, tools, and best practices on sustainable business, not to mention upcoming webcasts like this one, visit greenbiz.com and sign up for our free daily newsletter, GreenBuzz. On behalf of my colleagues at GreenBiz Group, thanks so much for joining today.